Here is my solution for the question I was given for my math video. My question is, the points plotted E at coordinates 4, 5, G, F at coordinates 7, 0, and G at coordinates 1, -4. Find all locations of H so that E, F, G, H is a parallelogram. Parallelogram obviously has two sets of parallel lines. So it could be one this way, and this way, and this way. And that's a parallelogram. So first, we're going to try to find our first one is we're going to find the slopes of each of these lines, as you can see. This is just to help with the process of finding the other locations of H. So quickly, from G to F, it is M equals 4/6. From E to F, it's M equals -5/3. And then from G to H, it's M equals 9/3. We're not going to convert that into number 3. It's just for later. It'll be easier. So first, we're going to see if we can find any point here that will make this a parallelogram. Because as you can see, if you were to put it right here, it look almost like a rectangle in square shape. That is a parallelogram. So we're going to try to find it. What we're going to do is, if it's somewhere around here, it'll have the same slope as this side. And from here to here, it'll have the same slope as that side. So going downwards from H, we're going to use the same slope over here. And so we're going to go down 6. And then move over 4. So it would go 1. Sorry, it would go down 4 and move over 6. So 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6. So it'll be plotted right here. So quickly, we're going to just draw a dotted line that goes through here. So now we're going to find the slope for here. And wherever this slope passes by, like the point of intersection is where point H will be slotted if it's obviously both, if it forms a parallelogram. So again, we're going to use the slope going this way for here. So that would be 5/3. It's -5/3, but because it's going up like this, we'll do the opposite and go up by 5 and then 3 to the left. So 1, 2, 3, 1, 2, 3, 4, 5. Just quickly just draw a dotted line going through there. And if you notice, the point of intersection is right here. So quickly, if we look at this, just by looking with our eyes, we can kind of tell that that is parallel to that, and that this is parallel to this. And then we can also tell by the fact that we know that this slope is the same as this. So that means these two lines are parallel, and this slope is the same as this. So we know these two lines are parallel. That makes it a parallelogram. So our first point for H is going to be right here at the coordinates of -2 to 1. So now we're going to look for another point. We're going to see anything on this side. So using this, we're going to use this slope and this slope, see if we can find one around over here. So quickly, using this slope, we know that it's 9/3. So using point F, we're going to go down 9 and then to the left 3. So that'd be right here. So we're going to draw just a quick little dotted line going through here. And then this slope, 5/3, we're going to do it down here from G downwards and draw a dotted line through that. So 1, 2, 5, 1, 2, 3. So quickly just draw a dotted line through that. So as you can tell, the point of intersection is right here. And so as, again, looking just from our eyes, we can kind of tell that these two lines are parallel and that these two lines are parallel. And again, we know that both slopes are the same on each side. So 5/3, 5/3, and then 4/6, 4/6, sorry, -5/3, -5/3, and then 4/6, 4/6. So this will be our point 2 for H, our second possible point for H. And so for our third possible point, we're going to be looking over here. Again, I've done this before, so I know that there is only a certain amount. So again, going this way, we're going to use the slope of this and the slope of this to find the possible point on this side. So using the point from G to H, the slope, we're going to do it from F upwards. So 9/3. And again, like I said before, this is why we didn't convert it to 3, just so we can use this type of slope to go upwards and get to our exact point. So 1. So right here, just draw a dotted line going up like that. And then here it's going to be 4/6. So 1, 2, 3, 4. And we draw a point line through there because that's where it meets up. And so that would be our final possibility for where H could be. Again, just by looking at the eye, by looking with our eyes, we can kind of tell that this is basically almost looks parallel, and same with these bottom ones. And again, we can just tell by the slope that they are both parallel. So these are the 3 possible points that I could come up with, and I think it's the only 3 points that could form a parallel. Again, here are H1. The point would be -2 to 1, and then our second slot for point H, which could be here, was coordinates 4, -9, and then our third coordinate that we found was 10, 9 coordinates. And then so these are the 3 possible coordinates I could come up with for our question, and all of these 3 are parallelograms, which make them qualified for the question. So yeah, this is my answer for my math question.